Hi everyone, this is Mr. Tukin, and this is a little tutorial video on how you can get 3.07 done. You can also be on the lookout. We'll get you some information on how you can actually earn your collaboration credit as well, since you are watching this video. In diving in, we're just going to kind of focus on the volume formulas you're going to need. You're going to want to copy down. You're going to need the volume of a sphere. And I'm going to write this off to the side real quick. We can kind of shorten this up here if you'd like. 4/3, if you want to feel free, just use 1.33. If you do 4 divided by 3, you get the number that runs on with threes forever, but it's okay to use just 2 decimal places. And again, I apologize ahead of time for my chicken scratch over here. That's 4/3 times pi over here. And pi, we can use the number 3.14. So when we go 2 decimal places, we're pretty accurate. It's accurate enough to get a good enough answer. So we're going to use that instead. And then we've got the radius cubed, whatever your radius is. As a reminder, a radius is the distance from the center of a circle to any point on the outside. So that value, when they tell us that, we're going to need that. It is very, very important to remember that when you have the radius cubed, you're going to need to take care of that first. So that's probably the worst looking R I think I could possibly draw. So my apologies there. So we're going to be using that formula today. Also, when they talk to us about half a sphere, when we're talking about a sphere, we're talking about like a basketball, soccer ball, bowling ball, a globe, the earth. We're dividing it in half. We're getting half the volume. When that happens, you're going to take the original volume and then you'll just simply divide it by 2. Of course, if they had a different type of division, like you could divide, if you could picture like kind of a quarter of a basketball, if you were to divide it into 4 parts, okay, um, you can get a quarter sphere. And if dividing or getting half a sphere was divided by 2, getting a quarter sphere, which we'll see later, is going to be the same as saying divide it by 4. So just a heads up, when you see us later and they're asking for a quarter sphere, we're going to find the total volume and then we'll divide it by 4 to get the volume they're actually looking for. However, we'll also run into one where it talks about the dimensions. The dimensions are something less. When we see that, we're going to do something a little different. We'll get into that shortly. The only other volume formula we're going to need is the volume of a cylinder. We're going to kind of attack it the same way. In this case, it's pi, as we see over there, and we're going to again use just 3.14, multiplied by the radius squared. So we'll see if I can make a little bit better R. That one's slightly improved. And remember, we're going to need to make sure that we actually square that value first. That'll be the first thing we're going to do. And then we're also going to multiply it by the height, which is just the letter h, the variable h. So whatever the height of your cylinder is. When you're looking at a cylinder, think of like a Diet Coke can, a pop can. If you like Pringles, the potato chip Pringles, those cans, that's an example of a cylinder. So we're going to multiply those 3 things. That's going to get us the volume of our cylinder. And same thing, if they talk about a semi or half cylinder, imagine you only filled half of it, and that's your volume. You cut it in half. So that's what we'll be dealing with. Again, we would, in that case, divide the overall volume by 2. Another thing we're going to talk about is like if you have a scale model, if they say it's 1/12 is the size, so you've got this original one and then you've got the scale model of it, literally every dimension in order to be a scale would use or apply that same scale factor. So if you did 1/12 times 60, that's the same as saying 60 divided by 12. That gets you 5. So notice when it was a 60-inch length here, the other scale of it goes down to 5 inches. The exact same car at a scale model would be 5 inches. And again, this was 96. They again multiplied by 1/12, or much easier, just divide by 12, and that's going to get you this 8. So the scale model would have these dimensions instead, is the example we're going to look at today. In the actual problem, you notice you've got this picture here. Now what I want you to realize is this is as if you're looking at this from above, like you're looking down at this big performance area, maybe at like SeaWorld or something like that. And you've got this sphere that's a main show tank, but it's actually just a quarter. It's a quarter sphere. Okay. And then you've got the holding tank, and imagine that Diet Coke can's kind of cut in half. So if you stacked them on top of each other, you'd have that. The other part that you can picture is like it's curved at the bottom. That's why you're looking at what appears to be rectangles, but that's from above. If you can imagine cutting a Diet Coke can vertically and then flipping them over, like opening it up, you're going to have like these long, almost like like a Twinkie kind of shape to it, where you've got a curved side, but then a flat other side. And that's what you're looking at with these holding tanks when we look at it from above. So now we're getting into the actual first problem where you've got this main shown tank that has a radius of 100 feet, but it's a quarter sphere. and it wants to know what is the volume. Well, let's remember when we get to that quarter sphere part, that's going to be the same as saying, hey, go ahead and divide by 4. So we want to make sure we remember that. Eventually, we're going to end up dividing by 4. And let's show this plugged into our volume of a sphere formula. So we're going to have, I'm going to start to type out because you actually should probably be typing it in your Microsoft Word document when you're doing it yourself. But we've got 1.33 times 3.14, and they told us that our radius is 100 feet. So we're going to go 100. This typing, by the way, that little rooftop means, hey, that's an exponent. The next number is an exponent. Well, remember, that's the same as saying 100 times 100 times 100. Okay, when we have 100 cubed. So you might get your calculator up. You're going to have a bunch of zeros, basically. But you can do 100 times 100 times another 100, and we're coming out with 1 million. So if I'm kind of simplifying this down, I'm going to have 1.33 times 3.14 times 1 million. I like to put the commas in just so I can keep track of how many zeros I've actually typed. Once you have that, you literally can come in here and just multiply straight across. So since we're ready, I'm just going to go ahead and multiply by 1.33 times 3.14. And that gets us our overall volume, which is 4,176,200. As a reminder, your units are actually cubic feet. Very, very important that you're putting the units as cubed. It doesn't mean we're cubing the number again. It's our way of saying you're looking at a volume. Now, the one thing I've forgotten to do here is this is if we had a whole sphere, but we don't. Remember, we've got a quarter sphere. So we're going to need to go ahead and divide that by 4. Okay, so if we divide by 4, that total volume, so I'm going to come over here with my calculator, divided by 4, and now we've got a final answer of 1,044,050 cubic feet. And of course, I ran out of space over here. Let me see if I can get that on there. There we go. That would be our example for the first show tank. Now, when you're turning this in, please check the actual assignment. If you turn in this data, you're going to get it wrong. We've changed the numbers on the assignment for you to work on, but this will guide you step by step on what to show and put for your teacher. You're just going to change the numbers and apply it to the problems that are given to you. The next one is talking about the holding tanks, and the problem itself can get a little confusing in terms of the wording. It's asking you what is the volume of each tank, so it actually is asking you for the half values. Remember, these are 2 half tanks, so the curved part's on the bottom, and then the top is kind of a flat. Again, picture like a Twinkie. If you put 2 Twinkies together, you maybe kind of have a cylinder looking thing. But picture a Diet Coke can, cut it vertically, and you've got the idea. You can smash them back together. That gives you the whole tank. So for this second one, we again are simply going to go and use the volume formula that they told us to use, which is the volume of a cylinder. But remember, we're looking for the half tank values. So we can come up here and again use the 3.14 times the radius. Well, in this problem, the example I'm giving you, it's 66 feet. But remember, that's squared. That's going to be the same as 66 times 66. And we do have to get that first. Remember, we need to get the radius squared part or radius cubed part for when you're dealing with a sphere. We have to do that first. This is a cylinder, so we're only going to square the radius. And it tells us in this problem, if we read it carefully, it's 140 feet. So we plug that all in. Then we're going to pull up our calculator, and we're going to get 66 times another 66. That's going to give us 4,356. So we continue down here. We've got 3.14 times 4,356 times 140. We've got all multiplication. It's okay to just simply multiply straight across. So I'm going to go times 3.14 times another 140. We've got this 1 million one again. So we're looking at a volume that's 1,914,897 and 0.6 or 0.6. Again, we want to remember that would be cubic feet because we want to express that, hey, we're dealing with a volume here. By the way, if you on your problems have more than 2 decimal places, it is okay to go ahead and round to 2 decimal places on it. We want to remember here, we're looking for, this is if we took those 2 holding tanks right here and we smashed them together. We don't want that. We need the half of it. So it's okay to go ahead and just say divide by 2 to get the half tanks, and be sure you express that to get each half tank volume. All right, we definitely want to do that. And so we just come over to this volume, we go ahead and divide it by 2, and we're going to get the volume as 957,448.8. Again, remember, we have to say cubic feet. If you just say feet, you're telling me a straight line distance. You're not telling me a volume. So make sure you have that in there as well. Those are the first 2 problems you're going to work on. Question 3 takes you back to that volume of a sphere, so the information from number 1. But the problem is, if you read this carefully, it says each dimension will be 1/8. Well, remember, that's not the total volume. We're not going back to number 1 and we're saying divide this by 8. Now, if I had said, I want you to tell me what is 1/8 the volume of the original volume, then sure. But this is saying 1/8 of the dimension. Well, our dimension was the radius. Let me go ahead and pause here for a sec. So in the first one, when it asks us about dimensions, the radius was 100. That was our only dimension because it's the volume of a sphere. Remember, if you read this carefully, they're only talking about the main show tank. So 1/8 of that would give us 12.5. So in our scale model, okay, in the scale model, the radius is equal to 12.5. And that, again, just so you can see it, that is 100 divided by 8, because that is 1/8. So we've got a radius of 12.5 feet. Well, this is asking us to get that volume of the mock-up tank with a dimension that's 1/8. So we're literally going to use a radius that is 1/8. So we're going to go ahead and plug into that volume formula the same way we did number 1. So you're going to see me go 1.33 again because it's 4/3 like we saw originally. And then we're going to multiply by pi, which is 3.14. We're going to plug in this time 12.5 inches, but remember, we're cubing it. We're doing 12.5 times 12.5 times 12.5 because that's what our volume formula says we have to do, and we have to do that first. We have to do the radius cubed in this case first. So over here, if we do 12.5 times another 12.5, we get 1,953.125. I'm going to round that to 0.13. If you don't round here, it's okay. It's not that long of a number, but if you want to, by all means, go for it. So we've got 1.33 times that pi, that 3.14, and now we've evaluated the radius cubed, and we got 1,953 points. I'm going to call it 13 because I've rounded up to that 1 decimal place. Once you've got that, go ahead. We get to multiply right across. So we get to go 1.33 times the 3.14. But therein lies one more catch. Think about what we had to do once we got the total volume on the first question. And again, here I'm going to do a little bit of rounding. If you thought about it by the time I got done typing, remember, this is if we had a whole sphere. Our original main shown tank was a quarter sphere. So we have to divide by 4 since it is a quarter sphere. And if we divide by 4, the scale model's volume is 2,039.16. I'm going to round to 2 decimal places. And remember again, it's cubic feet. The very last question is just asking you to compare them. In order to do number 4, you simply have to do the following. You have to get the correct volume from number 1. You have to get the correct volume from number 3. You divide them like you see here. So it says, answer the following question. The volume of the original main shown tank is blank percent of the mock-up. So you're kind of comparing the original to the mock-up, and that's going to get us a decimal, and we simply multiply that by 100 to create a percent. So literally on number 4, you're going to go ahead and take the volume of the first one, So our volume in the first one was 1,044,050 cubic feet. We're going to divide that by 2,039.16 cubic feet. I'm going to space this out a bit more. And we then take whatever that number is, and we're going to end up multiplying it by 100. So I brought up the calculator here. We've got 1,044,050 divided by 2,039.16. This gets us 512. It is not 512 percent. You have to actually multiply this number by 100. That's how much bigger the actual volume is compared to the other. So literally the answer, it's going to look really weird, really big. You can call it 51,200%. Okay, so you have to take, again, the original volume, divide it by the volume of the scale model, and then multiply that number by 100, and that gets you the percent. All right, so that's how you can do. You can use this video to guide you on each one of those. Go back and rewind it, pause it, play it when you're working on that particular question, and try it out yourself with the numbers they gave you on the actual assignment. If you've done this, you also can get collaboration credit. You can do this right now. Once you submit 307, go to the very end of segment 1. Go to the collaboration credit. You've watched this video. We'll give you credit if you can simply state that you watched 307 recording to help in completing the assignment, and go ahead and Google and answer this one question. How could you use the topics covered in the lesson and in this video in some kind of real world situation? Feel free to just simply Google search volume formulas in the real world. Look up an example of something you might need in that situation. That's going to be good enough. You do those two things, you get 20 points because you watched this video. All right, thanks. Hope it helped.